Hello everyone. In the last video, we touched about the concept of normal distribution, and I'm going to explain a little bit more about normal distribution. This is a very important concept in statistics, and it has a lot of relevance in option trading as well. And you can find a lot of thing, lot of information about normal distribution on the internet. What normal distribution says is it is a distribution. If I take a large enough population and if I plot the distribution of any attribute, any property that I'm talking about, I will get a shape of a bell, or this is known as normal distribution. So let me give an example. Suppose I'm taking the weight of all the people on planet Earth, and then I plot it. So this is what I will get: a curve in the shape of a bell. What it says is that most of the people would be here at the top, at the and this would be the mean. This would be the mean where majority of the sample, majority of the people would be centered at. And as I go to the left of it, I'll see that there will be lesser people who are, they say, if this mean is just a random figure, 100 pounds, and so there'll be very few people as we keep on going to the left, let's say around 30 pounds, and there'll be very few people to the rightest extreme, to the most right extreme, say 300 pounds. So but the majority of the people, majority of the sample would be at the peak, at the mean of about 100 pounds. So this is, we can do it in terms of any other attribute. We can take the height of all the people on Earth, and what we will get, we will still get a curve like this, which will say most of the people would be centered around the mean, and that mean could be 5 inches. And as we keep on going to the right, there'll be very few people, there will be very few outliers, and this descent to either the left or the right says there'll be fewer people here than the mean, even fewer people here than the mean, same over here. So this is what the normal distribution looks like. Now there are two important concepts in normal distribution. One is the concept of the mean that I talked about, where the majority of the sample, majority of the population would lie. And there is another concept known as standard deviation. What standard deviation says is how quickly does this normal distribution spreads out. So suppose it could, if I do another study on another planet, say, which is habited by human beings, I might get a curve like this, whose mean might still be at 100 pounds, but there be fewer people, say 50 pounds. There is nobody at 30 pounds, or there might be, but majority of the curve descends like this, and there are very few people at 50 pounds, there are very few people, say 150 pounds, and there are all sorts of people in between, but this number keeps on gradually decreasing. So what we have done, if I compare this graph, this normal distribution to this normal distribution, I can say that in this curve the data is more compact than this one, and I would say the standard deviation of this curve is lesser than the standard deviation of this curve, because this curve has a higher standard deviation, people are spread out farther, this curve is spread further out. And if I say go to some another planet altogether, where the mean is still 100 pounds, but there are people, I find people, there are a lot of people at 30 pounds, 50 pounds, and I even find somebody at 10 pounds. and if I'm finding somebody at 600 pounds. So and so this is the mean. Majority of the population would still be at the mean, but there are more outliers. There are more outliers in this curve. There are more outliers in this curve, and so I would say that the data is spread further out, and this curve has the highest standard deviation. So this curve has the least standard deviation, and the data is more compact, centered around the mean. This curve has moderate standard deviation, and this curve, this has the highest standard deviation, right? So this is the concept of normal distribution. And how do we use this concept in option trading? We can supplement this data by saying that the mean is the present price. Let me draw this again. If I just replicate this over here, and that's the mean. I would say the mean is the present price of underlying, and standard deviation is the volatility, of the option. And again, there could be curves like this, there could be a curve like this. For this curve, I'd say that it has, the data is more centered around the mean, and it is this is less volatile. So if the mean of the underlying is $100, the data doesn't go further to the left, doesn't go further to the right, just goes maybe $1.80 to $1.20. And for this curve, the data fluctuates very far. So if this is XYZ and the other curve is ABC, then we'll say, okay, even though the present price is $100, this goes up to $40, and it reaches up to $200. So this one, the curve, it's a high volatility, and this one has low volatility. This one, in fact, would be medium volatility. So this is the concept of how we use standard deviation and correlate it with volatility, and use it in option theoretical pricing model. Well, one of the important things just to notice, one of the important properties of theoretical pricing, or theoretical pricing model, and the properties of normal distribution curve. So suppose there is a normal distribution curve for anything, and this is the mean, and I'll just say standard deviation. The data would be spread like this. This distance is one standard deviation, say +1, -1. This data is +2, -2, and +3, -3 standard deviation away from the mean. And the important property is that anything within which is 2 standard deviation, +1 and -1 standard deviations away from the mean, that would be cover 68% of the population. So 68% of the population would be covered under this. If we go from +2 to -2, we would be covering about 95% of the total population. We go from -3 to +3, we'll be covering about 99% of the population.